Let us now consider example 2, where we have a voltage follower that's acting as a buffer amplifier. The gain associated with this type of operational amplifier is unity. We want to model this type of operational amplifier using a finite gain model to quantify the effects of our input and output resistances on our output voltage. We want to compare this to our idealized model. If we're given that our input resistance is equal to 1 kiloohm, our load resistance is equal to 10 kiloohms, our internal resistance is equal to 100 kiloohms, and our output resistance is equal to 100 ohms, given a gain of 10 to the fifth, we want to determine V sub out. To do such, we want to relate our input and output voltage. Thus, we're going to apply Kirchhoff's current law at node A. We have three currents exiting, I1, I out, and IL. Thus, I1 plus I out plus IL is equal to 0. And I1 is going to be equal to 0. Thus, I out is equal to minus IL. If we recall our governing equation for output current, we can apply Ohm's law to our KCL equation. I out can be expressed as V naught per R naught minus A times the quantity V2 less V1 per R naught, which would be equal to IL, or V naught per RL. Now, if we solve this in terms of our voltage differences, V2 less V1, which we'll call delta V, we have delta V is equal to V naught times the quantity 1 per A plus R naught per A RL. Now, we want to relate V2 less V1 to our input voltage. If we do a KVL around our outside loop, we'd have minus Vn plus delta V plus V naught is equal to 0. Or we can say our input voltage is equal to V naught plus delta V. Now, if we recall our expression for delta V that we just solved for from our KCL equations, we have Vn is equal to V naught plus V naught times the quantity 1 per A plus R naught per A RL. Or if we express this in terms of Vn per V naught, we'd have 1 plus 1 per A plus R naught per A RL. Thus, Vn per V naught would be equal to the quantity 1 plus 1.01 times 10 to the minus fifth. Or if we express this in terms of our gain, our output voltage per input voltage, V out per Vn is equal to 0.9999899, which is very close to unity, which is what the idealized follower amplifier will give us.